That's the hard part. All right, plus, I'll come back to that. I mean, I'm coming back to this. That's the hard part. There's a plus. What's n? That's easy. What's n? Look at it. What's n? Sine of 2x. That's easy. It's just a sine of 2x. M prime is easy.
1.
What's the derivative of x?
1.
1. I'll put it even. You don't have to write it, but I'll write it. Times a what? Times a 1. That's the hard part. And students miss it all the time.
You get the sine.
How do I do the derivative of sine of 2x? I have to utilize another rule.
Chain rule.
See? I have to use chain rule. Here I am doing product rule, and in the middle of product rule, I have to use what?
Chain rule.
Chain rule. And this is what Art was talking about when you use multiple rules. Right? Sarah, are you okay with it?
Oh yeah, I'm so sorry.
Oh, thank you, thank you. And Amber, if you still if you still have questions, hit me. Hit me, but right? So far, so good?
Where'd you get the 1 from?
Oh! So I did m times n prime plus n times n prime. M is right here. What's the derivative of x? Just 1. Does that make sense? It's like if there's a power rule. Add 1 in front, decrease it by what? 1. And I think from, even after a while, you'll get used to some of these. 10x always becomes 10, 5x becomes 5, 3x becomes 3, 2x becomes 2 when you do derivatives. You're like, well then what's an x become? What's in front of it? 1. All right, Ellen, would you give me the n prime?
Yep.
2
2.
cosine 2x.
Cosine of 2x times a? Cosine, I'm gonna squeeze in there. Here I go. I'm doing chain rule.
Times a
Cosine 2x times a?
2.
Times a 2. And I can do it like this, right? Can I write it like that?
Mm-hmm.
2 cos 2x?
Yep.
Are you sure?
You have to multiply.
You okay? Oh, good, good, good. I went okay? Awesome. Josephine?
Is there a, like, you know how there's PEMDAS for just regular functions? Is there a PEMDAS for the different rules that you can use to find derivatives?
Well,
Because
you could
said-
probably make your own cool acronym, but I got you. The order,
Yeah.
it's gonna change. There'll be some times where you start out with this or start out with that, and we have to recognize it when we look at the function. So that's why. Good question though.
So would you,
We looked at
but
this.
does product rule always come before?
Sometimes we have to do product rule and then chain rule in the middle, right? I don't think you'd see something where you're doing chain rule and then product rule afterwards. It would either be product rule before the what? Chain while in the middle of while you're doing product rule, and it would be the other option would be doing quotient rule. In the middle, you doing quotient rule, you got to utilize what? Chain rule. If that helps. Good. Hey, I want to know a great way to write this. You shouldn't leave it like that. You should always put coefficients in the front.
Mm-hmm.
What can I put way out in front of this?
2.
2x cos, let me get that x next. 2x cosine of
2x.
2x plus
Sine of 2x.
sine of 2x. You go, can I factor something? Nope. Not the sloppy, sorry. Maybe I can factor something out of that. Can I? No. But sometimes you might use that trig identity you talk about, the double angle. I had a student do that once, Art, on a test. I got my pen out to mark her wrong, and I was like, oh my gosh, that's the right, she took an answer that it looked like it, she used a double angle identity and wrote it another way.
Did
Like, wow, she did right. You know?
Did she get extra credit?
Oh my gosh, I saw it once in like 15 years. Haven't seen it since. But feel free to do it this year.
Will we get extra
No
credit?
problem. Nah. If I can create one that's pretty good, I'll let you know.
Okay.
So, and great job with that one. Hey, try this one. All right. This one usually gets some discussion going. So Josephine, we said you could do what? I mean, sometimes you'd be doing product rule, in the middle of product rule, you gotta use the what? Chain rule. Or sometimes you might be doing quotient rule, in the middle of quotient rule, you might have to do the what? Chain rule. Well, how about this guy? All right, sine of 8x, right? You all see the chain rule already?
Mm-hmm.
God. There's a couple ways to do this. Josephine, so this is gonna kind of help you understand why you asked your question. Is there like a phrase like PEMDAS, the orders? You could approach this problem two different ways. You could approach this as doing chain at the beginning. And while you're doing chain, in the middle of the problem, you gotta do chain again. You gotta do a chain with a chain. You go, what? Or you might look at this problem as product rule, and while you're doing product rule, do chain. Okay? You'll see why. I'm gonna do it both ways. I will do this both ways, but when you do it, everyone, would you do it the way you prefer? Okay? I'll be honest with you. When I grade a problem like this, I get less errors. I do. I get less errors if students look at this problem as starting with product rule. Because how many sine of 8x's are there? 2. So this is the first way I'm going to look at this problem. I have to differentiate this. I get less errors if students look at this problem as, let me write it right here, sine of 8x times a what? Sine of 8x. I get less errors. They call this the what? That's the first, this is the second. And they do, product rule. First times are the second, plus the second times are the first, right? And as you're doing that, do you have to somewhere do a chain rule in the middle? Yep. So let's try it that way. Let's try it this way. I get less errors. If you think of a problem like this. Because I'm sorry, that can get confusing. Look at that thing. Sine, parentheses, 8x, close parentheses, another parentheses, squared. So if I do product rule, m times n prime plus n times n prime, right?
Mm-hmm.
Okay, what's m?
Sine of 8x.
First time, that's tough. Maybe I'll do that later. What's that?
Sine of 8x.
That looks tough.
Mm-hmm.
All right, can you help me with the tough part? What's the derivative of sine of 8x?
8 cosine of 8 of it.
That's it? And when he took cosine of 8x, that was this part. And you multiply the chain. And you're sensing, you see when chain rule's needed. And when he wrote, here's going to be cosine of 8x times a what? 8. And where should I put the 8? Is it okay now that I put in that chain in front?
Mm-hmm.
I know in the formula it's written afterwards. But everyone's okay, I put that chain in front of there? Austin okay with this? Cool, no. So what would this one be? Wouldn't that be the same one? That's an m prime. Is an m prime going to be the same as the n prime?
Mm-hmm.
So this is another what? 8 cosine of what?
8x.
But everyone okay so far? I get less errors when students do this problem this way. Because you're going to notice something. The entire first part before the plus sign and the part after the plus sign are identical, aren't they? I get less errors. Students crush this. I rarely see errors when students do it this way. You know what you got? You got 8 sine 8x cosine x, and over here you got plus 8 sine 8x cosine 8x. And they are like terms. They are like terms. You got 8 sine 8x cosine 8x plus 8 sine 8x cosine 8x they're like terms. How many sine 8x cosine 8x's do you have?
2,
8 plus 8 is?
16.
But don't worry about doing it now. Hidden in there, I think you could use the double angle identity somehow.
Yep.
He sees it. That's where it would be, Belraj, try to get that extra credit. Do you see it?
So
And then
when
there.
when you added them together, you wouldn't have a 2, right? Because of the cosine?
That's right.
Okay.
That's right. I've got 8 of these. You're like, these are just 2 of these. You could have just said that. Hey, I'm going to have 2 of these, so 2 times 8, making it what? 16. Yeah?
So it will be like 8 sine A sine B, right?
That's right.
Huh.
That's it. Is that okay with that? Now, once everyone has this copied, we're going to look at it the other way. I get some errors that way. They think they got it. It's faster. It's faster, I think. I started this problem with what rule?
Product.
Product rule. And Amber, were you okay with this? Look it over. Everything good? Even those n primes?
Yeah.
I was like, oh yeah, I have to do the chain rule, right? I get less errors that way. But what if I start this problem as what? Move the 2 in front, right? Yeah. Yeah, exactly. You're like, I can do that. And that is totally fine. Please do it that way. But I do want to point out, I get more errors when students try it what? That way. I'll talk about it, okay? But Sarah, good.
I have one more question. So when you did that method, and so you combine 8 plus 8 is 16, I got that one right.
Okay.
But then when you combine sin 8x with sin 8x cosine 8x, right, with both of them, would that end up with square, like sin 8x cosine 8x?
I love it. It's a great question, and it wouldn't. We can treat these like gigantic x's. They're just like terms. Isn't that funny? It's like this whole funny thing. This sin 8x cosine x, you can think of it as just a giant like apple. It's like I got 8 of these apples plus 8 of these apples. And you can say I get 16 of these apples. You don't do anything, you don't multiply it or anything like that. They had to be identical though for us to add them together, and they were totally identical.
Okay. Yeah.
Which would happen every time in a problem like this. Because you got a bup. And so each time the n prime will equal the n prime. That's what's great about it, isn't it?
Mhm.
Good deal.
With this one, would you be able to do the chain rule within the parentheses with the square?
That's what we're about to do.
Oh,
That's where we're going. But I do want to point out, I get more errors that way, but please feel free to do it. It's the beauty of math, right? You can do mathematics different what? Different ways. The beauty of math. And I will get for my final answer what? 16 sine of 8x times what? Cosine x. Well, let's do it. Because there are people in this room who are going to prefer this. They're going to, oh, that was a lot easier. You know, but I do when I grade, and I see someone try, I'm like, he tried to do it the fast way and he missed something. I'll show you what kind of answers you get. First, so let's start out. Ready? We're doing it this fast way. All right. Where can I move that to?
In front.
Front.
And look at this. Big parentheses, decrease it by what?
1.
1. And then over here, I'm going to multiply g prime right here, right?
Mhm.
Y'all follow me? I'm just going to put g in here. G's going to go here. And then g prime will go here. Does everyone agree?
Mhm.
So tell me, what's g? Sine of what?
8x.
Sine of 8x. So you okay if I put sine of 8x in there?
Yep.
All right. Josephine, I want to make sure you're comfortable with that. Look, 2 in front, decrease all this by 1, I put my g back.
and the 2 in front was taking the F.
Yep, power rule. So far so good? Make sure she's got it. So now everyone, I have to do g prime. So what's the derivative of all that?
Cosine.
Can you do it? What's the derivative of sine of 8x?
8
And you're like, oh, that involves chain rule. Here you are, you and I are doing chain rule, now we gotta do another trick. So right here, I have to take the derivative of sine of 8x. What's the derivative of all that?
Cosine 8x.
Now I'm asking you, did we get the same answer?
Yes.
Look it over.
Cosine.
Did we get the same answer?
Mhm.
2 times sine of 8x, all to the first power, times, now I'm gonna multiply the chain, g prime, what's the derivative of this? And 8 cosine of 8x. And this final answer becomes, 2 times 8 is?
16.
If you like it, do it. I just want to tell you multiple answers I get. I get 2 sine 8x times 8. I get that all the time. Like the cosine of x just kind of disappears. Cool? So be careful with that. I get some strange answers on that one. Cool. But a lot of you may prefer this. You know why? You may go, this was faster. You find it like quicker. You just gotta be organized, you gotta make sure that this is your entire what? There it is, and then my whole G prime chain has to be that. But if you notice carefully there, when you did a chain with a chain in there, right? It's like two chains. Good deal. Question?
I just wanted to say that since it's in the parentheses, that becomes G, right?
Mhm.
Whenever something's in the parentheses, it becomes G.
I know, you're always trying to identify what's this, what? What's this G of X? And a lot of time, where is it?
In parentheses.
I know. And you go, when isn't it in the front? I think when they do the y equals e to the 3x stuff. Okay, there's no parentheses, but we know that's our what?
G.
That's the G, right? Good deal. But even when they, look. Does anybody remember a natural log derivative?
1 over x.
I'm gonna put it over here. And Sarad's gonna help me do this problem. All right, that derivative was 1 over x. Okay? Let's try this. Guess where the G is?
3x plus 5.
So watch how we do this. The derivative of ln of x is 1 over this. Look at this. So let's see how this works. The derivative of ln of x is 1 over that part. So I'm going to do that. ln of x, 1 over that. So to the derivative of this, 1 over
3x plus
that.
5.
I just did the f prime of g of x. I still haven't done the g prime part. Do you all see what I did?
Mhm.
Look, ln of x became 1 over x. So derivative of this would be ln with derivative y equal to ln of 3x plus 5 is 1 over the 3x plus 5. But now, what's the g prime?
3.
And Sarah, the g was that 3x plus 5, right? What's the derivative of 3x plus 5?
3.
And I have to put it up in the numerator, right?
Mhm.
So I can put it here. Where else could I write it? I would put it over times that 1. What's 3 times 1?